Thank you very much for joining us here on TRT World. Can you explain the significance of this breakthrough blood test in cancer research and its possible implications for early detection of cancer?
Well, we know that the early detection of cancer is the key to curing the disease. And we know that many people walk around not knowing that they've even got cancer. This initial study, looking at symptomatic patients, patients who have perhaps anemia, weight loss, abdominal pain, demonstrates that this simple blood test can actually be used to detect cancer early, and then obviously one can go on and do other treatments, particularly surgical treatments. And this is particularly relevant to those cancers that are so hard to diagnose, those internal in our bodies like lung cancer and pancreatic cancer. So this could really, really boost their ability to detect tumors early.
And what makes it different from other existing cancer screening methods?
Well, it's new technology. The idea that you can just take a blood sample and detect not only whether an individual has cancer, but also where the cancer is. These little bits of DNA that are shed into the blood from tumor cells give a signature of the origin of the tumor. And we don't have anything like that at the moment, anything as sensitive as that. Now, the test at the moment isn't perfect, but it's developing all the while. And this initial study demonstrates the potential of such of this powerful technology, where just a simple bit of blood can help you diagnose tumors early.
Wow, that is fascinating. And I wonder, how does this breakthrough align with the current efforts to improve cancer screening and treatments? And what areas of cancer research do you feel will be impacted most by this development?
I think there are two big areas. One is the initial diagnosis. And as I said earlier, we know that early diagnosis and screening has been so effective. For instance, in breast cancer, the reason we've seen such a remarkable increase in patient outcome, in survival in breast cancer patients, is very much attributed to early diagnosis. Again, early diagnosis is important, but this test can also help us monitor response to therapy. So once you're been diagnosed and you're having chemotherapy, we need simple tests that just allow us to know whether or not a patient is responding, and measuring this tumor DNA in the blood will help us to monitor patients' response to therapy. So it is a very significant breakthrough, and it's something that we hope in the future, with increased sensitivity, could be used as a screen for everybody. There's currently another trial going on in the NHS of hundreds of thousands of people who have no symptoms whatsoever. We know that many people are walking about who have cancer but don't know they have it. And I think having a routine test that you could take every few years once you reach, say, the age of 50 would be of remarkable benefit, not only in preserving people's lives and their health, but also alleviating all the pressures on health systems and all the costs of anti-cancer therapy.
And doctor, as you may very well know, post-COVID, patients are not able to get to their GPs. There's a huge waiting list. So do you think this new test is going to help with the waiting list somehow?
I think it's too early, because the test cannot be applied routinely yet. It needs to be developed further. It needs to be tested further. And you're absolutely right. One of the terrible outcomes of COVID is this enormous backlog, and also the reluctance that people had to come forward for normal screening. So we do have existing screening programs, and what we just need to do is put as much effort into continuing those programs, including the imaging. MRI imaging is so important in cancer diagnosis. But there is a big backlog. This test will take a few more years to become useful routinely.
All right, fascinating insights into the topic. Professor Lawrence Young, thank you very much for talking to us here on TRT World. Really appreciate your taking out the time.
Thank you.